this is something important for you guys who do the designing and stuff. I added this in last night, that's why it's not on the agenda. But every time you come to a junction or a detail around the building, there's 1, 2, 3, 4 or 5 maximum important principles when you come to doing a detail. So if we take the detail at the base to the ground, 1, 2, 3, 4, 5, 1. Normally we would recommend, not as much as possible, that you keep the panel away from the ground to prevent splashback, and it ensures the air can enter into the cavity space. 2, perforated protection profiles, allows the air in but stops rats, mice, birds and everything else getting in. Alright? Panel to form a drip. What I mean there is just drop the panel just down below the ventilation and everything. No risk then of anybody seeing this, and to make sure the water drops off and doesn't come back in underneath on these things. No planting in front. Yeah, what can happen there? Well, apart from blocking, it starts growing up the inside of the cavity. Yeah, and path or some kind of protection if you're down near a car park, or as we seen on the job yesterday, they had that metal thing around the side to stop trolleys and everything banging off of it. Yeah? Yeah. Yeah. No matter how good we are or how bad we are on impact resistance, if you have one of your trucks with a tow bar on the back of it, it's going to bust it in smithereens. So normally what you'd have is either bollards or a footpath or something in front of it in the design process. It's not like, what I'm saying to you is a lot of this isn't your responsibility, but if you see it happening, it gives you very good credit marks with the architects or whatever if you raise these as potential problems for them to sort out. External corners. Only a couple. The corner of the panel should be supported somehow. Yeah. There is special corner brackets and corner pieces to do that. Joints can be left open or they can be closed. Okay. One option to be careful of here is in the design process. Is particularly if you're on a high wind load building or facade where, can anybody tells me if the wind hits, okay, so the wind is coming from this side, from the left hand side, hitting this facade. What happens to this side here? It increases the wind load pressure on this side. What will happen is, I'll stand over here out of the way so you can all see. The wind will come, it will hit this, get pushed out this way, it goes into a swirly effect here and causes more suction on that corner. There's also a risk if the joints are open and this is a ventilated cavity that you experience extra pressure coming from the back of the board as well during a high wind scenario. So in higher wind areas and stuff like that, it is recommended that a baffle or something is put in there that makes it easier to it stops the transfer of pressures from one side to the other side in the cavity. What could happen in a bad situation is that you may need rivet fixings in the corners, maybe 200 centers or something. Put in the baffle, it can go back up to 400 centers. Okay? Just to bear that in mind. And normally if we're on a system like this, we're normally 350 millimeters where the panel has to get some kind of fix back to the structure. We can overhang 350, have an angle bracket there, and the same back this way. If not, there is special brackets available or can be made up that actually run from the corner and give you the corner protection. Okay? By the way guys, that's the very traditional way of doing it. This seems to be the hot, latest, top of the charts way of doing it at the moment. Alright? Yeah, okay, yeah, because it's much easier and faster and we don't have to do a special cut on it. Yeah? But there's loads of options available. Some people use these fancy metal trims or whatever on them as well and things like that. But there's a few options for them to do it. But the principles remain the same. Internal corners are the easiest. Just full support of the panel, open or closed joints, I don't mind. Parapet, what's wrong with that detail? mean, that panel should shoot up here a little bit more, huh? Right. By the way, this for you guys is, and for how everything works, this is the safest system, right? The latest trend at number 2 in the rock charts is having no capping showing on the top and just having the panel finishing. Yeah? My life would be so, no, it's not your fault. You're only about 2 years later behind everyone else that's doing it. What this does is, by having the capping as well as stopping all the water, don't forget now, principle is we've got, you know, because it's a ventilated and drained cavity, yes, it would take away the water, but you don't want to introduce loads and loads of water into the cavity space. So you protect at the top. It also forms a nice area to cause a vacuum to draw the air up through the building as well. So we don't block it. Between a 20 and a 50 mil gap across here between the panel. The cover should be 50 millimeters generally. Could increase to 100 depending on how tall the building is. Prevent rain entry into the system. Okay. What normally would happen on the other one is something like, if our panel is coming up here, normally we would end up having everything running to the inside. So the air has to go to the inside of the wall system. We have water protection and a rivet system here that clamps the two together, but the air still can come out through the front, so we've got to bring the air through the back of the construction. Okay? And if it's some of the materials, we might ask for something like this on the top. Special flashing system, clamped here, fixed back here, but the air can allow to escape out through the inside of the building. Okay? Movement joints in buildings. Okay, another scenario, not allowed to cross the movement joints, no special requirement for our material, just don't fix it across. We use an option of T and L rails together that allows everything to move and slide. Okay, now this is an important point in this detail for when you're fixing it. If the architect as the engineer has decided that this must be a 20 millimeter wide gap here for the expansion of the building, yeah? What should this end up being? What do we normally put in ours? 10. However, if he wants 20 movement in the building here, what should this be?
20.
At least 20. If you put 10 there, this is where thinking outside comes. And all of a sudden, that's the design for a 20 millimeter movement. You're going to start buckling the panels, risk of breaking the panels on the outside. Okay? Bear that in mind. So I'm afraid you're going to have to look at the engineer's drawings at least once before you fix it. Windows, something similar with parapets. This is just higher wind load areas. Allow air to escape. The air must always escape out. 10 millimeter gap. If this is a 10 millimeter gap left here, there's no need to put in any protection. Only where your gaps are more than 10 millimeters, say more than 10, 12 millimeters, should you start considering using perforated profiles. All right? Now, we're protecting against birds, vermin, rats, whatever else. I don't know whatever else critters you have over here, snakes. But since we got St. Patrick, we have no snakes in Ireland. He stood on Crow Patrick and banged his stick a couple of times and all the snakes just left the country. Honest to God, we have no snakes in the whole island. Okay, in the UK and in Britain they have loads of snakes. And most of them are walking around on 2 legs. Boom, boom. Okay, get back to serious business. If it's a 10 millimeter gap, there's no need for it. If you're ending up with gaps bigger than that behind parapets and things, use some kind of protection, stop the birds building in there. Okay? Now, the next question about birds and vermin and protecting against them. What else can get into the cavity spaces and cause problems?
People going to stay here.
Yeah, free housing, yeah. Okay, it's a bit narrow. Spiders, wasps, hornets, bees. Yeah? They are a problem. Are they? How many properly ventilated cavities have you seen where bees are building inside them? If you find spider webs, if you find bees, if you find wasps coming out of your cavity space, That's the least of your problems. Because you know that there's no airflow or air movement in there, and you're going to have bigger problems with condensation and water than you will ever have. These critters don't like living in windy areas. If the cavity is working properly and the air is blowing and ventilating, they will move on and find someplace else to set up their homes and their nests in much more sheltered locations. Okay? So on inspection, when people are looking, if I find spider webs on things, I normally say, okay, there's a problem with ventilation, look further. Overhangs, provision. Same way with the head. Must allow the air to enter the cavity space. Bigger 10 mil gap, perforated profile. Like to form a little drip here. It's just a nice detail just to make sure that that's just a little bit lower. There. Now, what is critical when it comes to windows is the position of the window. We can have windows back here, we can have windows in line with this part of the line, we can have windows here, we can have windows here, and we can have windows here. Okay? And a lot of it has to do with the jambs on the side, which I'll show you here now. For narrow reveals, you're probably better off as installers going for a metal reveal system that's part of the window frame that just clips onto or fixes onto the window, right? Because fiddling about with small pieces of fibre cement, you know, it's just wasting your time and all the rest, and you're not really going to gain anything on it. Personally thinking, I think we should be at least 3 or 4 inches, 75 to 100 millimeters in new money, you know, for a fibre cement reveal. So when time you put in the fixing, at least it's a decent size. Like here. What is important is the junction back here. We have things called F profiles or U profiles. And these for you guys are fantastic. I don't know if you've ever used them or whatever, but basically you fix it to the window frame, the panel slots into it. You don't have to worry about getting fixing on the inside, you don't have to worry about sealing it, you don't even have to worry about having a fantastic cut on the panel because it's hidden away. And these things are usually available. We do some of them, but usually the window companies have them as accessories as well. And then all you've got to worry about is just getting a fixing here on the outside, and the inside is totally sealed. You can get your mastic sealants, whatever, done very simply and very easily. Okay? However, what is important with the jamb and the sill junction is the relationship of where the sill finishes with the jamb. Down here. You call that the jamb or the reveal?
Yeah.
Yeah? Which one?
Reveal.
You're leaving it open when I ask, yeah? Both, okay. For the side and the bottom on the sill, it is important that the sill, you're normally using pressed metal sills. If you are, you've got to make sure that there's a return up on the edges of the pressed metal sill. What happens is when water is flowing down glass, and particularly on big windows, and the wind is blowing, it'll blow it all in one direction, and you get huge concentrations of water in this area here. What you don't want to start doing is permitting that water to get into the cavity space. Okay? Because you're only asking for trouble. Eventually it will drain away and stuff, but however, if your backing wall details aren't done 110% properly, you're just inviting trouble to enter. So having these turned up, the panel comes down on the outside and covers them over. You can leave a little gap here, any water blows in, hits this, trickles back out to the front and drops down the building. Okay? Perforations is something that's getting a little bit more important, or not important, it's getting a little bit more trendy. With the architects and things like that, they want to mix it up a little bit. So we have a full installation guide on what you can do and you cannot do. We do have certain rules for where the holes can be taken out and what has to be left around the materials. Okay? The document is freely available. What is important is the size, the shape, the minimum amount of material that's left around, and the minimum edge distance, which is always 100 millimeters. But other than that, we can be pretty free to do whatever we're doing inside in the panel. Okay? People ask me, oh, you're cutting a lot of the panel now, what about the wind load? But actually, the more panel we cut out, the less the wind load is a factor, because there's no panel for the wind load to attack. However, for you guys, be very, very careful with perforations through it. You've got to make sure that the backing wall and everything is beefed up to handle the excess water that's going to blow through here. On a rainy day, if you have holes, I don't know if you can see them just barely, that's not a 10mm gap. That could be a 60mm hole. It could be a 100mm hole. The amount of rainwater that's going to drive through there is going to put the backing wall and the insulation and everything under more pressure than a normal facade would do. So just bear that in mind. The architect will draw this up, but he probably won't change what happens with behind the construction. We have a series of technical notes that are coming out now as well, where we deal with certain issues and stuff, and we write up loads and loads of crappy information on it, and to explain the do's and don'ts. Basically a lot of the stuff I've covered here today. Okay.